Alright, let's graph sine of x. Y is equal to sine of x. What that means is we're going to take all the sine values, which is here, 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 and all the way across these values, and we are going to plot them in an xy coordinate plane, and we're going to sketch the graph of that. Okay, so these are the second values. Those are my sine values. I am going to take them to do that. Okay, so that's a lot of numbers I have to plot. So let's make it easy on ourselves, and we don't have to plot all of those numbers. We'll just plot a few of those. That's my x and y axis. Okay, and I got to make sure I have enough room here for my y axis here. Now, if you go all the way around the circle, you're starting at 0 degrees and then going all the way around, which is 360 degrees. So we'll call that 0 degrees. We'll call that 360 degrees. Okay. First, I'm going to graph everything in terms of degrees, then I'm going to show you how to do it in radians. Okay. Then I'm going to start cutting everything in half. So halfway between 0 and 360 is 180 degrees. Halfway between that is 90 degrees, and then halfway between 180 and 360 is 270. And so we're just going to take a look at 0, okay, 90, 180, 270, and 360. And that should give us an idea of what the values of a sine function are. Okay, then we can go from there. If you notice, the largest value occurs right there. So the most the sine can be is 1, so we'll call that 1 on the y-axis. The smallest y value occurs here, which is negative 1, and we'll call that negative 1. So, now I'm going to start plotting these points. At 0 degrees, the value is 0. So that's 0, 0. At 90 degrees, the value is 1. So at 90, it's going to be 1. 180 degrees, the value is 0. So we're back to 0 again. At 270 degrees, the value is negative 1. So I'm going to go down here, negative 1. And at 360, the value is 0 again. So I'm going to go back up to 0. So my sine curve connects like this. Okay, it comes back down and goes back up. And there it is. That's one full period. And it keeps repeating over and over and over. So if you were to graph this in radians, which you have to do, okay, same function, same graph. Okay, I'm going to graph this in terms of radians. So the highest is 1, the lowest is negative 1. 0 radians. And if you go all the way around the circle, that's 2 pi. Okay, same as 360. Halfway between that's pi, halfway between that's pi over 2, and halfway between pi and 2 pi is 3 pi over 2. Okay, I'm going to start when it's 0 radians, sine is 0. At pi halves, sine is 1. At pi, sine is 0. At 3 pi halves, sine is negative 1. And at 2 pi, sine is 0. So I'm going to connect the dots. Oops. Messed up a little bit. So that's my peak. It's going to come back down. It's going to hit my low value. It's going to go right back up. And there it is. Same curve, except it's in radians. Okay, now let's graph cosine. Y is equal to cosine of x. And do it in terms of radians. Okay, again, cosine is the first value, so we're going to graph this number, plot that number, and back to this. Okay, we don't have to graph them all. The highest value is going to be 1, just like sine. The lowest value is going to be negative 1. 0 degrees, okay, and then it goes to 360. we're going to start cutting everything in half. Half of that is 180 degrees. Half of that is 90 degrees. Half of that is 270 degrees. Okay, 0. When the angle is 0, the cosine value is 1. So I start here, and then it's 90 is 0, 180 is negative 1, 120 is 0, and at 360 is 1. And then I'm going to connect my dots. Okay. Come back down, and there it is. Okay, that's my cosine graph. Y-axis, my x-axis. Okay, if we do the same thing in terms of radians, it's going to look the same, except my x values are going to change. So I still get 1 and negative 1. Okay, 0, and then I have a pi. Halfway between that's pi over 2. Halfway between that is pi over 4. 2 pi, excuse me. And, sorry, let me change that. The period is 2 pi. So halfway between that, 0 and pi is pi over 2. Halfway between that, pi and 3, or 2 pi is 3 pi over 2. Alright, in radians, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. Ends up where it started again. So it's coming back down, come back up, coming back down, so on and so forth. That's my cosine curve. Now, tangent curve, that's the next one we want to graph. Y is equal to tangent of x. Tangent of x is really sine of x divided by cosine of x. But remember, I have a denominator, so anytime I get a 0 down there, it's going to be undefined, so I'm going to get vertical asymptotes. So where is cosine 0? It ends up being 0 at pi over 2 and negative pi over 2. At pi over 2, okay, I can't have anything there, so I have vertical asymptote there. At negative pi over 2, I can't have anything there because cosine turns into 0. The next thing I need to know is, well, what kind of values do I get? Well, when I put in a 0, I'm going to put in 0 of tangent. Tangent of 0, which is same as sine of 0 over cosine of 0. And we know sine of 0, just looking at the unit circle, okay, it turns out to be 0 over 1, which is 0. So I get that value. And then I want to pick a value between 0 and pi over 2, about pi over 4. So when I put in tangent of pi over 4, find that. That's the same thing as sine of pi over 4 over cosine of pi over 4, okay, and that's really 1 because both sine and cosine are the same. So I get a positive 1 right there. So my curve goes up and flattens out against the asymptote. And then if I try negative pi over 4, okay, now negative means I'm going down the unit circle, so I'm looking at that value right there. This is the same thing as negative 45 degrees, or negative pi over 4. If you notice, okay, sine and cosine have different signs, meaning the sine is negative, cosine is positive, so I'm going to get a negative 1. So negative 1, and this goes cup down, okay, and it looks like that. Alright, now when you look at these three functions, the period of sine, period, okay, is 360 degrees, or in terms of radians, is 2 pi. And that same thing here for cosine, the period, okay, is 360 degrees in degrees, and the period is 2 pi in terms of radians. Period means where it starts all over again. Well, tangent curve has the distance from here to here is just a pi. So tangent has a period of just pi, not 2 pi, or 90 degrees. Okay, and then tangent curve repeats all over again. So if I were to extend this out, okay, I'm going to have another vertical asymptote, and it's going to look like this, and that's going to be at pi, so on and so forth, and we'll have vertical asymptote here, and then we'll get another curve like that. But we don't have to draw all those, okay? We just have to draw them. Okay. Now, what I want to do is, I want to finally graph secant and cosecant, okay? And then show you how they're related to sine and cosine. Okay, and there's a relationship there. So let's go down here, clear that one. Okay, let's graph y is equal to cosecant of x. Well, cosecant is really 1 over sine. So if I were to graph sine of x, I just need to flip it. Okay, but notice I have a denominator. So I can't, anytime sine is 0, I have to have a vertical asymptote. So first I'm going to graph a sine of x. Okay. And this is 0. Let's do it in radians from now on. So that's 2 pi. Half of it that's pi. Half of it that's pi over 2. Half of it that's 3 pi over 2. Okay. And I have a 1 and I have a negative 1. So my sine starts here, goes up there, the top, gets back to the middle, okay, goes down, gets back to the sine curve looks like that. I'm just doing a dotted line because I really want to graph a cosecant. Okay, so everywhere is 0, which is here, here, and here. I have to have a vertical asymptote because whenever sine becomes 0, it becomes undefined. Cosecant becomes undefined. So I get that. And I'm going to draw dotted lines for vertical asymptotes. Now, rest of it is easy. Whatever the point is right there, I'm just going to take this curve right here, I'm going to flip it up. So it looks something like a parabola, but follows the asymptotes. So I'm going to take this one, flip it down, because it's a reciprocal. And that's done. And then the period for cosecant is 2 pi also, or 3/16. Okay, what about secant? Y is equal to secant of x. So secant is really 1 over cosine. So we're going to graph a cosine curve, okay, and then we're going to flip that. So let's go ahead, call that 1, call that negative 1, 0 to 2 pi. That's my x-axis and y-axis. Okay, half of it in that's pi, half of it in that's pi over 2, half of it in that's 3 pi over 2. Okay, and then I'm going to go a little bit to the left side, call that negative pi over 2. Okay, cosine, or 0, where? Well, cosine is 0, it starts here, okay, and at pi half is 0, and goes down to negative 1, comes back to 0, and then goes back up to the top, and of course goes down to 0. So my cosine curve, which looks like this, has zeros. Okay, and it has 0 here, here, and here. So that's where I'm going to get my vertical asymptotes. Because I have a denominator, my denominator can never be 0. And then 1 over cosine means to flip the cosine curve. So when I flip this up, it looks like a parabola. And I take this, flip it down, it looks like that. And of course my period is 2 pi also, or 360 degrees. Okay, now one more basic graph, which is a cotangent. Okay, y is equal to cotangent of x. Well, cotangent is really cosine of x over sine of x. Right? And that means I have a problem whenever sine is 0. Well, where is sine 0? Well, let's figure that out. Okay, sine is 0 at 0. Okay, and sine is 0 at pi, and sine is 0 at 2 pi. So everywhere I have that, everywhere I have a 0 for a sine, I'm going to get a vertical asymptote. So I'll call that 1 if you want. We'll call that negative. Extend this a little bit. Call this negative 1. Okay, so I'm going to get x-axis and y-axis. So I'm going to get a vertical asymptote here. I get a vertical asymptote here. I get a vertical asymptote here. Of course, my tangent curve look like this. Okay, when I flip that, because this is cotangent is really 1 over tangent. Okay, so when I flip that, my cotangent curve looks like this. It goes through pi over 2. Okay, cup up, then cup down. And then this is going to be 3 pi over 2. Cup up and cup down. And of course my period is pi. Alright, but I don't have to draw all of these. I can just draw one period and I'll be fine. So you don't have to really draw this, just one period will be fine. So let me clear everything and let me redraw everything for you. Y is equal to sine of x. Look how easy it is. It looks like this. It starts here, goes up, comes back down, goes back up. That's it. That's your sine. That's my y-axis. X-axis. That's 1. That's negative 1. 0 to 2 pi. Middle is pi. Middle of that is pi over 2. Middle of that is 3 pi over 2. And you're done. What about y is equal to cosine of x? Well, cosine of x starts on the top, whereas sine starts at the origin, or in the middle. Okay, so it's not that hard. Call that 1. Call that negative 1. Okay, so I'm going to start here. Okay, I'm going to go down to the low point, come back up at the high point. Well, from here to here, okay, that's my 0 and that's my 2 pi. In the middle of that is going to be pi. That's when it's going to hit the negative 1. Okay, in the middle of that is going to be pi over 2. In the middle of that is going to be 3 pi over 2. Okay, tangent curve. Y is equal to tangent of x. Tangent of x goes through the middle. Okay, it's cup down and cup up. Got arrows at the end. It's got a vertical asymptote here and a vertical asymptote there. And that's my y-axis, and that's my x-axis. Okay, that's my 0. This is going to be pi over 2. It's going to be negative pi over 2. Okay, what about y is equal to cosecant of x? That's really this, okay, flipped. So I'm just going to vertical asymptote here, here. That's really sine of x flipped. So I'm going to have vertical asymptote there, there, and there. And when I flip that curve, okay, this one will look like this, and then here it's going to go down, looks like that, because I have my vertical asymptote, follows the asymptote. Okay, looks like that. Okay, what about y is equal to secant of x? Okay, secant of x is related to cosine of x, which is this one right here. So every time this turns into 0, it turns to 0 there, negative pi over 2. I get a vertical asymptote here, get a vertical asymptote there, get a vertical asymptote there, and I just flip, and there it is, and I flip this one, and there it is. And what about y is equal to cotangent of x? Cotangent is really tangent. You slide this over, okay, and when you slide that over, it goes to pi over 2, and then you flip it. So it looks like this. When you flip it, cup up and cup down, and that goes through 0. My asymptotes are 0 and pi, and that's my x-axis, and that's my y-axis. Okay, and the period of that is pi. Alright, one thing I want to also graph is when you change the period. What happens when you have y is equal to cosine? Oh, let's do sine. Okay. So y is equal to sine of x over 4. Well, this here is same thing as sine of 1/4 x. This is known as the frequency. So the period is not the same anymore, it changes. So what it means is to find the period, okay, you're going to take 2 pi. You always take 2 pi or 360 degrees, but we're doing in radians, so you divide by 1/4. When I do that, that ends up being 8 pi right there. So now the sine curve still looks the same, so I'm going to graph it exactly the same, okay, I did before. I start in the middle, I go up, come back down, go back up. Okay, so this is going to be 1 and that's going to be negative 1. Okay, only thing is 0 to 8 pi. That's my x-axis. My y-axis, half everything that's 4 pi, half everything that's 2 pi, and half everything that is 6 pi. And that's it. Okay, and then what happens if I do something like this? Y is equal to 5 times sine of 1/4 x. Well, now this value here, instead of having 1 and negative 1, that's called my amplitude. Okay, and that changes. So instead of having 1 and negative 1, this will be 5, and that will be negative 5. And that's known as my amplitude. Okay, so let's do with the cosine this time. Only thing is I'm going to change that number a little bit. Instead of 1/4. Okay, let's say we have y is equal to, let's say, 4. You know what? Let's do negative cosine of 2x. But first of all, this 2 is going to change that, and my period now is going to be 2 pi divided by 2, which is pi. Okay, so what it means is after a pi, it's going to start repeating again. This is my amplitude. Amplitude is always positive, which is 4. But the negative sign in the front will do something to it, so let's go ahead and sketch the graph of that. Okay, so here we go. So I'm going to get 4 and negative 4. 4, instead of 1 negative 1, I'm going to get 4 and negative 4. Okay, and then my period is, we said it's pi, so I'm going to call that 0, call that pi. Start cutting everything in halves, so pi over 2, and this would be pi over 4, and this would be 3 pi over 4. Okay, normally cosine curves start right there, but because of my negative sign, I start at the bottom. Okay, everything is flipped. So I'm going to go up, go across the middle, so it's going to look like that. It's going to hit the peak at pi over 2, so it's going to go up to the top, and then come back down here, so back to 0, and then finally end up where I started again, is right there, and then I've got to go back up. Oops. Got to make sure if I mess up, then you guys will get careless and mess up too. So that's my low point. I got to make sure I'm showing you that this is my low point. Okay, and then I come back up. Okay, and that's my low point here. My x-axis and my y-axis. And there it is. That's when you have a negative. Okay? Alright, so that's it. So those are the graphs of 6 trig functions. Okay, sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. 6 trig functions. Basic 6 trig functions.